implicit differentiation, for us to get a better understanding of implicit differentiation, I think we also need to get a better understanding of the difference between implicit and explicit. So if I asked you to solve for y explicitly, that means that you're going to put y on one side and get all the x terms and the constant on the other side. So you're getting y by itself. So that means that for these values of x, this is what I will get for y. So it is explicitly telling us, okay, substitute these x values in and I get this particular y. If I'm looking for the circle, I'm hoping that you could at least do 1, 2, and 3 when you did the do now. Now you may have different for the do now exam for 4. What is the difference between explicit and implicit? You could have looked that up on the internet if you need to, but explicit is plainly or directly expressed, whereas implicit is not plainly expressed or expressed indirectly. And some examples, I just gave some real life examples. If you tell someone explicitly that you love them, you say, I love you. But implicitly, you can also show someone that you love them by giving them a hug or a cuddle or lots of other ways, like doing something nice for them. So you can imply something without saying it explicitly. Well, the same works for this. I can, if I looked at the equation of a circle, I am implying that there is a relationship between this x and this y. So I could substitute in values for x in the original equation of a circle and find corresponding values for y without having to solve for y explicitly. That is the difference. Now, I just put in here question 5 as a little bit of a review, just to keep in mind that the difference between d of dx, which is an operation, and dy dx, which is the derivative once the operation has been taken. So it's saying take the derivative of y with respect to x. That's dy dx, where this d dx means, all right, take the derivative of whatever comes next with respect to x. Example 1, part A, is pretty straightforward. We're taking the derivative with respect to x of 4 of x to the fourth, so that it gives me 4x cubed. And then technically, I'm supposed to use the chain rule. So if I use the chain rule, I could say, okay, well then times the derivative with respect to x of x, which is 1 or dx. Oh, that's a highlighter. That's not helpful. That's dx over dx. Just like if we'd had u to the fourth and we did dx of that, we would do 4 u to the third times du dx, just like when we did the chain rule. In this case, well, dx over dx is just 1. That's why we tend to not write it. So we haven't written it so far because it's just going to be 4x cubed. Well, the same idea goes for part B. It's saying, okay, take the derivative of y to the third. So we're going to use the power rule. So 3y to the second it becomes, but I have to use the chain rule. I'm taking the derivative with respect to x, but it's y. So you have to multiply by the derivative of y with respect to x, because using the chain rule, the inner function is actually y and the outer function was x. Now I want you to try C and D on your own. Don't forget, in part D, you have to use the product rule. So I want you to give them a shot on your own first, and then see if you get the right answer. So part C, I got 3. Technically, it's 3 dx over dx, but we don't write dx over dx because dx over dx is actually equal to 1. So then it's unnecessary to write that. Minus 5, using the chain rule, I have to take the derivative of y with respect to x. And then part D, the derivative, or the first, that's 3x cubed, times the derivative of the second is 2y, but don't forget the chain rule, dy dx, plus the second, which was y squared, times the derivative of the first, which was 9x squared. Using the chain rule, it would be dx over dx, which we don't need to write. Let's polish it off a little bit. So then we get 6x cubed y dy dx plus 9x squared y squared. And that's example 1.